Hello, my name is Scott Dolan, and thank you for taking the time to view our poster and for showing interest in the research I'm about to tell you about. Before we dive right into the poster, I would like to acknowledge Alexei Perkudin and Leonard Gamberg from Penn State Berks, along with Daniel Petoniak, Sterling Gordon, Elena Bullion, Marcus Diefenhaler, Ted Rogers, Wally Melanchuk, and Ubu Sato for their contributions to the study. As you can see from the title of the poster, The Origin of Hadron Production and Deep Inelastic Scattering, this study is focused on gaining a better understanding of the intrinsic motion of the partons that make up the nucleon. One way this can be done is by studying a process called semi-inclusive deep inelastic scattering, also known as SIDS. In this reaction, a high-energy electron scatters off a quark within the nucleon. This quark forms a hadron in the final state, such as a pion, which is detected along with the scattered electron. There are several regions that the produced hadron could be found, which is a dilemma related to the analysis of data for SIDS, and we have developed a tool that can help guide us in determining which region the data belongs to. Shown in this picture are the four regions found in SIDS: the hard transverse momentum current region, the target region, the soft central region, and the transverse momentum dependent or TMD current region. Using ratios, which are defined with parameters describing the underlying parton kinematics, we are able to gain some insight on which region the data is in. For the TMD region, ratios R0, R1, and R2 are used together, and if all three ratios are much less than 1, we say the data is in the TMD region, or the probability is high. Shown in this plot is an example using the ratios to visualize this probability with what we call affinity using pseudodata for electron-ion collider. Affinity is coded with purple color when affinity is large, and red when affinity is low. It can be seen that a high affinity is associated with a high probability, and vice versa for a low affinity. The plot also tells us that for large q-squared pt and low z values, the affinity is very high, and suggests we are in the TMD current region. At this point, these ratios can be considered a tool to guide us in this study, but further research needs to be performed to compare the results with the phenomenological fit using the factorization theorem models we know work. This study can also help guide future work with the electron-ion collider, which will be built in the future in the United States at Brookhaven National Laboratory. I'm looking forward to seeing you at the CEU meeting during my Zoom presentation of this poster. Thank you.